Alright, in this example, our original function is the f of x is equal to negative 2x plus a half, or 0.5. And they want us to stretch this line by a factor of 4/3 in the horizontal direction. So our new rule then, the new rule is this. The new line is going to be the old line. So, and we're going to evaluate that at 1 over the stretch factor, 1 over the stretch factor times x. Alright, now the stretch factor in this case is 4/3. So we're evaluating the function at 1 over 4/3 times x. Well, if you were to divide 1 divided by 4/3, just a little side note over here, 1 divided by 4/3 is the same as 1 times 3/4, which is 3/4. So when you divide 1 by a fraction, the answer is the reciprocal. So this is actually being, x is being multiplied by 3/4. So this is 3/4 x. So the new function is simply the old function being evaluated at 3/4 x. Now what does that mean? That means that any place that we see, so let's put the old function down here. The f of x, remember, was negative 2x plus 0.5. Okay? So any place that I see an x in the original function, I'm going to put in 3/4 x. So now I could make that 0.75 as well. So I could also say we're going to evaluate the function at 0.75x if decimals, if you feel more comfortable with the decimal. Alright, so the new rule then is going to be negative 2 times 0.75x plus 0.5. Okay? And negative 2 times 0.75 is negative 1.5x. And then we continue on with plus 0.5. Alright, so that is our new rule. This has an effect of having a horizontal stretch by a factor of 4/3 or 1 1/3. So for every coordinate, and let's go ahead and graph that so you can see. We'll get rid of these. Okay. Alright, so if I were to go ahead and graph the original function, which in this case was negative 2x, negative 2 times x plus a half plus 0.5. If I graph that, that's what it looks like. Okay. Now I'm going to go ahead and graph the new function that we had, which was, so let's go ahead and do that one, graph new function here. So we're going to go negative 1.5 times x plus 0.5 Did I not plot that? Hold on a second. Graph, plot function. There we go. So, if I were to take a point on this line, so we're going to display the, let's go to this line here. Go to this line, which is our original one, and we are going to construct a point on the line. If I were to take that point right there, and let's put it at a place that's really easy to find along the x, which I think is right here. Okay? If I were to go ahead and display the, let's see here, the coordinates, there, I'm at 3, negative 5.49. Okay? Now, if I were to take a point on this line, so let's go ahead and we're going to construct a point on that. And if I were to place it at approximately the same location, okay, so now let's go ahead and measure the coordinates of that point. See, that one is at, see if I can get this to match up. There we go. So notice that what we've done here is we've taken our original function and with the exact same y, both negative 5.49, that's actually 4, 3.99 is actually 4. I have taken and stretched the x portion of this by a factor of 4/3. If you were to multiply 3 times 4/3, 3 times 4/3, you would get 4. 3 times 4/3 is 4. So we've stretched the x coordinate, the x part of this point, we've stretched it over by a factor of 4/3.